Welcome everybody to the part 5 of this video series on limits that I've been making. In this video also we will be covering one particular type of questions. I don't know what heading to give it, but yeah, all the questions that are in this video are of a particular type. Now in all these questions you will see that the denominator is not a single term. It's a term of the type a plus b or a minus b. It might be square, it might be cube, it might be something. But it will be of the type either a plus b or a minus b. Like here you have pi by 2 minus x as your denominator. So in all these questions what you do is you take the entire denominator as a single term, and here we will take that pi by 2 minus x as h. Now see, x tends to pi by 2, which means that x is approximately equal to pi by 2, and if x is approximately pi by 2, pi by 2 minus x is going to be approximately equal to 0. So we can say that h tends to 0. And also if you check from here, the value of x will be pi by 2 minus h. Now with all these transformations, this limit can be written as limit of h tends to pi by 2. We are changing our variable from x to h. So the limit of x, which was tending to pi by 2, is now replaced with h tends to 0. Cosec x minus 1. So we will write it as cosec of x was pi by 2 minus h minus 1, the whole divided by, this was taken as h, so we have the square of h in the denominator. Okay, so we have h square in the denominator. Cosec pi by 2 minus h is like cosec 90 minus h, that is sec h. So we have sec h minus 1 in the numerator. Sec h is 1 upon cos h, and 1 upon cos h minus 1 is like 1 minus cos h, the whole upon cos h. Okay, now 1 minus cos h upon h square, we all know that this will be equal to half. For all those who don't know how it is equal to half, you can refer the previous video that I have made, and also I have mentioned it in the previous video also that if at all you are writing this in your college exams, you cannot directly write it as half because this is not a standard result, it is only a shortcut. And for all those who want to know how to write it in your college exams, again you can refer the previous video that I have made. So for the time being, I'll directly write it as half and go ahead with the solution. This will be half because limit of h tends to 0, 1 minus cos h, and we have h square in the denominator. You can put the value of h as 0 here. So cos h will be cos 0, which is 1. So the final value will be half upon 1, which is equal to half only. So that's the final value of the first question. Moving on with the second one, we will divide the numerator and denominator with x minus a. So in the numerator we have sin x minus sin a upon x minus a, the whole thing divided by fifth root of x, which is like x power 1 upon 5. It's divided with x power 1 upon 5 minus a power 1 upon 5 divided by x minus a, and that's your numerator and that's your denominator. In the next step you can split the limit as well, so there will be one limit in the numerator and one limit in the denominator. Now the denominator is of the type x power n minus a power n upon x minus a, and the value for that will be n into a power n minus 1. So n into a power n minus 1. So 1 by 5 minus 1, that would be minus 4 upon 5. And that can be written as a power 4 upon 5 in the numerator. We will do it in the next step. So this will be 5 goes to the numerator. A power 4 by 5 is what we have in the numerator. And then we have limit of x tends to a. See, definitely you can take x minus a as h and proceed in this question, but we need not do it in this question because there's an easier method. The numerator is sin x minus sin a, and we can write it as 2 cos of x plus a divided by 2 into sin of x minus a divided by 2. That's the numerator, and in the denominator you have x minus a, which we will prefer to keep in the denominator of sin. We will take this 2 also in the denominator right here, and after you split the limit, one limit goes with the first term, and the second limit goes with the second term. So we have 5 a power 4 by 5 into, if I put x as a in the first bracket, I have cos of a plus a, that is cos 2a divided by 2, which is cos a, into the second term is like limit of, I know it's x tends to a. If x tends to a, x minus a will tend to 0, and if x minus a tends to 0, x minus a upon 2 will also tend to 0. So limit of theta tends to 0, sin theta upon theta, that will be equal to 1. So we have cos a into 1, and finally the value of the entire expression is 5 a power 4 by 5 into cos a. Okay, That's how we are solving the second question, and with that we go ahead with the third one. Because we see a root in the numerator, we can rationalize this, and we can rationalize it with root over 5 plus cos x plus 2 divided by root over 5 plus cos x minus 2. That in the numerator will give us 5 plus cos x minus 4, that is 1 plus cos x divided by pi minus x the whole square, into, we will be left with 1 upon root over, okay, there's a plus 2 here, 5 plus cos x plus 2 in the denominator. So let's keep this as one term, and when you just put x as pi in the second term to evaluate that second term completely, this will be cos pi, which is minus 1. 5 minus 1 will be equal to 4, and root 4 will be equal to 2. So here we have 2 plus 2, which is equal to 4. So the final answer, whatever you get, I mean the value for this limit, has to be multiplied with 1 upon 4. So we have 1 upon 4, then we have limit of x tends to pi, 1 plus cos x divided by pi minus x the whole square. Now here is where we use the standard method that we are learning in this video. The denominator is of the type a minus b, and that is why we will prefer to take it as h. So if I take pi minus x as h, I know that x tends to pi, that is if x is approximately pi, pi minus x will be approximately 0. So h will be approximately 0, and I can say that h tends to 0. Also, if I rearrange the terms here, I will have x as pi minus h. Okay, so this entire limit, it's going to get rearranged as x tends to pi, so that will be h tends to 0, cos x, that x will be written as pi minus h, divided by pi minus x is what we are taking as h. So the denominator is h square. Cos of pi minus h will be minus of cos h. So we have 1 minus cos h divided by h square, and this was a shortcut that we have learned in the previous video. This will be 1 by 4 into half, and that will be equal to 1 upon 8, and this is the value of the third question. Moving on with the fourth one. The denominator is of the type a minus b again, so we can take pi minus 6x as h. So from here we can say that if x tends to pi upon 6, if x is approximately pi upon 6, then you can write x as pi upon 6, cancel off that 6 and 6, and pi minus pi will be 0. So pi minus 6x will tend to 0, that is h will be approximately 0. So we can say h tends to 0, and if h tends to 0, we can start rearranging this entire expression as limit of h tends to 0 cos of, now in place of x, pi minus 6x, right? So we can write pi minus h equal to 6x. We can bring that 6 here, so x will be pi minus h the whole upon 6, that is pi by 6 minus h upon 6. So cos of pi by 6 minus h upon 6 minus root 3 times sine of pi by 6 minus h upon 6. The whole divided by pi minus 6x, we are taking it as h. So we have h in the denominator. This would be limit of h tends to 0. We can expand this bracket and we can write it as cos pi by 6 cos h by 6. So cos pi by 6 is cos 30, which is root 3 by 2. So root 3 by 2 into cos of h by 6 plus sin pi by 6 into sin h upon 6, that is 1 by 2 into sin h upon 6. Expand this bracket also. So that will be sin pi by 6 cos h upon 6, that is 1 by 2 into cos h upon 6, and there's an into root 3 also there. So minus root 3 by 2 into we have cos of h upon 6, and finally the second term in the bracket will be negative. But when it expands with, when you expand the bracket with that minus root 3, the second term will become positive. So plus we will have root 3 into sin h upon 6 and cos pi upon 6. So that will become 3 by 2, because it will be root 3 into root 3 by 2 and sin of h upon 6. Okay, that's what the entire expression becomes, and the whole thing divided by h. Now root 3 by 2 cos h upon 6 minus root 3 by 2 cos h upon 6 gets cancelled, and we are left with 1 by 2 sin h upon 6 plus 3 by 2 sin h upon 6, and that will be 2 sin h upon 6. And we have the whole thing divided by h. You can pull out that 2 common, I mean, you can take that 2 outside the limit. So we have limit of h tends to 0, 2 coming outside the limit. We will bring a by 6 here and we will multiply it with 6 so that the entire thing gets balanced. That 6 can be taken out and written here. This was h tends to 0, okay? So now we have limit of theta tending to 0 sine theta by theta, which will be equal to 1. And the final answer is 2 upon 6 into 1. That is 1 upon 3 into 1, which is 1 upon 3. So the final value for this bracket becomes equal to, the final value for this expression becomes equal to 1 upon 3. Moving on with the fifth one. Okay, we can actually write the numerator as limit of x tends to 1. It's 1 minus x into 1 plus x, the whole divided by sine pi x. And we will split that 1 plus x and write it as limit of x tends to 1 and 1 plus x. And that will be a separate limit altogether. When you put x as 1 right here, this becomes 1 plus 1, which is equal to 2. And we can let that 2 remain the way it is, or we can write it outside the limit here. Okay. Now we can take this 1 minus x equal to h. So if I say 1 minus x will be equal to h, x was approximately 1. If x is approximately 1, h will be approximately 0. So I can say h tends to 0. And this limit can now be written as 2 times limit of x tends to 1 gets replaced with h tends to 0. Then in the numerator we have 1 minus x, which is equal to h upon sine of pi into x will be replaced with this. So if 1 minus x was h, 1 minus h will be equal to x. So we have sine of pi into 1 minus h. Expanded, this becomes pi minus pi h. Sine of 180 minus theta is sine theta. So this will be sine pi h. Take that h in the denominator. So you have upon h here. And you can split the two limits. One limit goes to the numerator and one in the denominator. But limit of a constant will be a constant only. So it's okay if you don't write the limit in the numerator and just write it in the denominator right here. We bring a pi here, and to balance that pi we multiply with a pi here. That pi goes outside and we have 2 upon pi into 1 upon limit of theta tending to 0 sine theta by theta will be 1. So into 1 upon 1 is what we have, and the final value for this expression is 2 upon pi. Moving on with the first main question of the second main question. First question of the second main question. So here also the denominator is pi minus 6x, and that is why we will take it as h. Okay, so we can say that x will be equal to, take that 6x on the left, you have pi minus h, take that 6 on the right, it is pi by 6 minus h upon 6. And yeah, x was tending to pi by 6, so when we put x as pi by 6 here, we realize that h will be approximately equal to 0. X was approximately pi upon 6. So h will be approximately equal to 0. So we can say h tends to 0. And this limit becomes equal to limit of h tends to 0 2 times sine of, in place of x we are writing pi by 6 minus h upon 6 minus 1 the whole divided by h. This becomes limit of h tends to 0 2 times, open the bracket, sine pi upon 6 into cos h upon 6. Sine pi upon 6 is sine 30, which is half. So half into cos of h upon 6 minus cos pi by 6 into sine h upon 6. So cos pi by 6 being root 3 by 2 into sine of h upon 6 minus 1 the whole divided by h. If I expand the bracket here, I have cos h upon 6 minus root 3 sine h upon 6 and a minus 1 in the end. So what we can do is we can keep this cos h upon 6 minus 1 together and minus 3 sine pi, minus root 3 sine h upon 6 as one term. So when you split the two terms, or let's just say I'm writing it like this, minus 1 plus, this is one bracket, this is the other bracket, split the two terms, so there will be one h you have in the denominator here and one h that you have in the denominator here. Okay, let's just write this again. So we have limit of h tends to 0, minus 1 plus cos of h upon 6 divided by h, and I'm splitting the limit. Okay, so the second term is minus limit of h tends to 0 root 3 sine h by 6 divided by h. Let's simplify the second term first because that will be easier for us. Upon 6 and into 6. That into 6 is what we will take outside. So we have a 6 here. Root 3 also goes out. And finally this is like limit of theta tending to 0 sine theta by theta. So the value for this will be equal to 1. Try to simplify this. So we will have h square here. And to balance that h square, we will bring an h in the numerator also. So limit of h tends to 0, this entire term being multiplied with h in the numerator. We will take out a minus common from here. So we will have minus h outside the bracket. So limit of h tends to 0 and a minus h over here. Okay. This is h upon 6. So we need the square of it right here. So we divide this by 36 and 36 comes here. That 36 can also be taken out. And now finally when you try to evaluate this bracket, limit of theta tending to 0, 1 minus cos theta upon theta square. The value for this bracket will be equal to half. So we have half as the value here. But minus h upon 36, when you put h equal to 0, the first term becomes minus 0 upon 36, which is equal to 0 only. The first term is 0 into half, which is equal to 0. Minus root 3 upon 6 into 1. So this is 0 minus 6 can be written as 3 into 2. 3 can be written as the square of root 3. So when you cancel root 3 in the numerator and denominator, you are left with minus 1 upon 2 root 3. And that will be the final value. Minus 1 upon 2 root 3. That will be the final value of this expression. Okay. So with that we continue with our second question. And again you have to do the same very thing that you have done in the previous sums. You only have to take 4x minus pi as h. If x tends to pi by 4, x will be approximately pi by 4. And when you put x approximately as pi by 4 here, you realize h will be approximately 0. So h tends to 0. The limit now becomes limit of h tends to 0. Root 2 minus cos of, in place of x, you can put h plus pi the whole divided by 4. H plus pi the whole divided by 4. So we can write it as h by 4 plus pi by 4 minus sine of, we again have h by 4 plus pi by 4 the whole divided by 4x minus pi, that will be equal to h, and we have the square of it. This becomes limit of h tends to 0. Root 2 minus, if you expand this, it is cos h by 4 into cos pi by 4 minus sin h by 4 sin pi by 4, but you have to open it along with the minus sign here. So that will be cos h by 4 and into cos pi by 4 will be 1 by root 2. There was a minus sign in the middle when you were expanding this bracket. But when you open up the full bracket there with the minus sign, you are going to have that middle minus sign getting converted to plus. So the second term will be plus sin h by 4 into 1 by root 2. Then we have this term also. So when you expand it and along with the minus sign, okay. So that will be minus of sin h by 4 sin h by 4 cos pi by 4, which is sin h by 4 into 1 by root 2. And then we have again a minus sign because in the middle there was a plus. But when you expand it along with the minus sign, the last term becomes minus. Cos h by 4 into sin pi by 4, that is 1 by root 2. The whole thing divided by h square. Okay. Now we have two terms getting cancelled, that is sin h by 4 into 1 by root 2 and sin h by 4 into 1 by root 2 get cancelled. Minus cos h by 4 into 1 by root 2. So you can actually combine this term and this term together. They are one and the same terms. It's like minus x minus x. That will be minus 2x. Okay. So this entire term will be equal to minus 2 times cos h by 4 into 1 by root 2. Keep in mind 1 by root 2 is actually multiplied with cos h by 4 and not only with h by 4. So it's minus 2 into 1 by root 2 into cos h by 4. Okay. This gets cancelled. I mean 2 and root 2 in the numerator and denominator get cancelled, giving you a root 2. You can pull out that root 2 common to have root 2 into 1 minus cos of h by 4. And in the denominator you simply have h square. H by 4. So in the denominator we need the square of it, that is h square by 16. You multiply it with 16 to balance the 16 that you have introduced. That 16 can be taken out of the limit and you can write it separately. You can also pull out this root 2 common. And finally you have this entire expression in the form of the shortcut that we have learned. 1 minus cos theta by theta square, and the value for that expression will be equal to half. So we have half as the value of this bracket multiplied by root 2 upon 16. You can cancel off root 2 here and here. So you will be left with the final answer as 1 upon 16 root 2. 1 upon 16 root 2 is the final value of the given expression. Moving on with the third one and the last one in this video. We are going to do again the same very thing, that is we will take 6x minus pi as h, and if x tends to pi upon 6, that is if x is approximately pi upon 6, you can put that x as pi by 6 here, and you will realize that h will be approximately 0. So we will say limit of h tends to 0. In the numerator it is 2 minus root 3, then it is cos of x. From here you can see very clearly that 6x will be h plus pi. So x will be h plus pi the whole upon 6, that is h upon 6 plus pi upon 6. So we have cos x, and x will be written as h by 6 plus pi by 6 minus sine of h upon 6 plus pi upon 6. The whole thing divided by, this is already equal to h, that is 6x minus pi, we were taking it as h. So the denominator is h square. We can expand the numerator, that will be limit of h tends to 0, 2 minus root 3 into cos h by 6 plus pi by 6. So that will be cos of h by 6 into cos pi by 6, which is root 3 by 2, minus sin h by 6 into sin pi by 6, which is 1 by 2. If you open up the bracket, this will be root 3 into root 3, and that will give you a 3 here. So we have 3 by 2 cos h by 6 minus, it will be root 3 by 2 because there was a half here and we were multiplying it with root 3. This is minus root 3 by 2 sin h upon 6 minus, expand the second bracket, that will be sin h upon 6 into cos pi upon 6, that will be root 3 by 2 into sin of h upon 6, and the last term will be minus cos h upon 6 sin pi upon 6. So cos h upon 6 sin pi upon 6 will be equal to half. Now if you check out the terms, we have, okay, there was already a minus sign in the middle here. When you were expanding this bracket, there was already a minus sign in the middle. When you were multiplying it with this minus, this term was becoming plus. So we had plus root 3 by 2 sin h upon 6, which gets cancelled with the term here, and you are left with minus 3 by 2 cos of h upon 6 minus 1 by 2 cos of h upon 6. That makes it minus 4 by 2 cos of h upon 6, that is minus 2 cos of h upon 6. You can pull out a minus 2 common from there, 2 common from there. You will be left with 1 minus cos of h upon 6 divided by h square. We bring a 36 here, and to balance that we bring a 36 here. We are doing that because we have h upon 6 here, and the result was 1 minus cos theta upon theta square. Theta is here, theta square is here, so we needed 36 in the denominator, which is why we brought that 36, and we are balancing it by writing a 36 here. So if I remove that 2 upon 36, which is basically 1 upon 18 outside the limit, I have 1 upon 18, and then limit of h tends to 0, 1 minus cos theta upon theta square, that will be half. So the answer is 1 by 18 into 1 by 2, which is 1 upon 36, and that is what is the value of this entire expression. So yeah, that's how we are solving this third question, and with that I am done with covering whatever I wanted to cover in this video. I hope that whatever contents I have covered have been someplace somewhere helpful to you in your preparations. Thank you for watching.